In this tutorial, you'll learn how to use the follow behavior for virtual parenting and dynamic following. To get started, let's open the included tutorial scene. Our target object will be this red sphere, animated randomly using the noise behavior. To demonstrate the basic setup, let's add the follow object to the Timeflow view, and then right-click to add automation, follow. In the inspector, we can see the settings. Let's drag the red sphere object into the target object field. With the default mode direct, the current object is now placed in the same location as the target sphere. We can add an offset to more clearly see the object. This setup is helpful in situations where you want to attach one object to another without having to reparent them in the hierarchy. Another option is the target distance, which keeps the object a certain distance away from the target, allowing it to follow behind. We can also limit which position axes are applied using these checkboxes. For example, we could turn off the Y position to keep the object on the XZ plane, or position following can be turned off entirely. Rotation is applied separately below and is optional. If we select Match Rotation, the object is assigned the same rotation as the target object in world space. Or we can select Look At mode for the object to remain facing towards the target object. The rotation features also have the ability to toggle each axis or enable limit rotation to specify a range of rotation. Use Smooth Time to apply temporal smoothing, having an overall dampening effect. And we can adjust the object's orientation and up vector if needed. The last rotation mode uses the object's direction of movement, which acts like auto-rotate. To see this in action, we need to re-enable position following. Back at the top, let's go over some of the other modes. Lerp is similar to direct mode, but includes temporal smoothing. This can be used to create smoother or even sluggish following movement. The smooth damp mode is similar to Lerp, but uses a different method of calculation, causing the object to accelerate faster when it is far away, and to slow down as it approaches the target object. And then Smooth Approach performs following behavior based on speed rather than time. Lerp Local Axis is just like Lerp, however, each axis of movement can have its own smoothing value. This can be helpful to provide more flexibility or to dampen follow behavior for each axis of movement. And lastly, we have Physics Mode. When this mode is selected, you'll see a warning that this mode cannot be previewed in edit mode since physics requires runtime to preview. However, to have some preview of the behavior in edit mode, you may select a fallback mode as a proxy while editing. Using physics is an advanced feature which we won't go into detail in this video. But for a brief overview, this can be applied to objects with a rigid body component to apply follow behavior using one of the physics force modes. Please refer to the documentation and example scenes for further use of these features. Which mode you use for the follow behavior depends on the overall effect you're going for, and there's a wide range of possibilities. For now, we'll return to using the Lerp mode and turn off Use Rigid Body. With any of the modes selected, additional limit settings may be applied to further control the movement. If Limit Velocity is enabled, the object is prohibited from exceeding the speed limit set in world units. With Limit Position enabled, you may set position limits on each axis to keep the object constrained within a set range or bounding region in world space. The Limit Distance feature can be used to turn off following behavior when the target object is either too close or too far away. The object only follows if the target is further away than the minimum distance and closer than the maximum distance. Next, we have the start position and rotation settings. This determines the initialization state of the object when a scene starts or loops. If none is selected, then these settings have no effect and the object starts at its current position in rotation or its last saved state. If original is selected, the transform coordinates are stored as the starting point upon first starting the scene. This mode is helpful for scenes that loop or replay to ensure that the object starts in the same position as when the scene was first loaded. Or you may use the Set mode to specify specific starting position and rotation in world coordinates. And lastly, the On Target mode places the object at the target position and rotation upon starting. This mode is useful when using follow for virtual parenting or object attachment. Which mode you use, of course, depends on the type of following behavior you need. In the last section, we have the Close Gap slider. Use this to force the object closer to the target. When Close Gap is set to a value of 1, the object follows directly with the target. This can be helpful to transition an object from following behind to being directly on the target, or vice versa. and the overall blend slider may be used to control the final amount of influence the follow behavior has. If overall blend is set to 0, the object stops following the target altogether, and at a value of 1, the following behavior is fully applied. Either of these sliders may be animated to transition following behavior on and off over time. One final tip when using the follow behavior is to select late update in the update settings. Since calculations are based on other object movements, using late update ensures that follow is applied after everything else and produces cleaner results. Anytime you observe jitter or shaky movement, check that late update is set. Or alternatively, you could use update after to chain multiple follow behaviors together. That concludes this tutorial on using the follow behavior. Please refer to the documentation links in the video description below. Next up, we'll go over using the look at behavior.